Hi, in this video, I want to talk about the integrating factor method for solving differential equations, but also how that method teaches us about the general idea of solving differential equations. So for differential equations, especially the equations that we will learn in this introductory class, there's this one big idea, and that is in solving a differential equation, you try to make an educated guess of the solution. Make an educated guess as to what the solution is. What helps afterwards is that if the existence and uniqueness theorem is applicable, then it will help assure that our guess is the solution. That's big idea number one. Big idea number two is that we're not wildly guessing. We will base our guess on the derivative rules that we learned in Calculus 1. For example, we learned in Calc 1 that the derivative of a power is also going to be a power. And in fact, it will be some sort of a lower power. The derivative of exponential will be another exponential. The derivative of a sine and cosine will be some other form of sine and cosine. And then there's the product rule. The derivative of u times v is u prime v plus u v prime. Those rules will help us make educated guesses as to the solution of the differential equation. All right, let's take a look at this example. Solve y prime plus 2y over x equals 3x cubed. Let's start by making guesses. We look at all the things that we learned in Calc 1. We look at this and we try to see which one of these rules will help us. So there are different ways of solving this equation, but right now I'm thinking that this equation may look a little bit like the product rule. Because right here I have a y prime, that's like a u prime. And over here I have a y, so that's like a u. It looks like the two terms in the product rule. So what about a v? Well, it looks like v cannot really be equal to 1 because in that case v prime would not be equal to 2 over x. So I'm thinking, wait, maybe the v got cancelled out. So maybe v is not equal to 1 at all, but it may be equal to some factor I that used to be multiplied in each term, but it got cancelled out at some point in the past. So my guess is that this is a product of u times v, where u is equal to y and v is equal to some factor I that was cancelled out. Okay, so we're going to put it back in. Y prime I plus 2 over x times iy is equal to 3x cubed I. And v is I. V prime is 2 over x times I, and that's how it fits the product rule formula. And the whole thing is my uv prime. Well, I have my v prime, which is something times I, and I have my v, which is equal to I. So if I divide it side by side, I get v prime over v is equal to, and the i's cancel, I have 2 over x. Note that I will always have this because v prime always has a factor of I and v is always equal to I, so I can always have v prime over v. So that means I can always take the integral with respect to x and always end up with ln of v on the left plus c, right? And for convenience, I'm going to set c equals 0. So that means ln of v is equal to 2 times ln of x. And I take e to the power both sides. I get v is equal to x squared. So now that I know that the factor used to be x squared that got canceled, I'm now putting it back. I'm going to multiply both sides by x squared. And all of the left is the derivative of the product of the x squared factor that I just put in and the y. Okay. And I have, I take integral both sides. Then on the left, the derivative goes away. And on the right, don't forget to put in plus c. Then I solve algebraically for y. All right, let's check the answer. Let's plug it into the original differential equation to see if it works. Okay, y prime, the derivative of y. So I take the derivative of y plus 2 over x times y. So I'm going to distribute the 2 over x. Okay, cancel, cancel. It is 3x cubed, so it does solve the given equation. All right, let's go back and see what happens. I'm given an equation of the form y prime plus p of x times y equals to some function q of x on the right side. Then the idea is I want to multiply throughout by some function I of x, some factor I that is a function of x. Then where's from? I is v. V is x squared. X squared came from e to the power of 2 ln x. Well, that 2 ln x came from the integral of 2 over x. Now, first of all, the left side of this calculation is always going to be v prime over v because I always have v prime multiplied by something, and v, I assume, is my factor I. So it always in that form. And so it's always going to be ln of v is equal to the integral of the 2 over x, which is q of x. So I is always e to the power integral of p of x dx. And if I do multiply both sides by I, then the left-hand side is always I times y, the derivative of that product. Okay. And the right-hand side is the original q of x times I. So in summary, this is what happens. We're given the equation y prime plus p of xy is equal to q of x. We're going to set I as e to the power of the integral of p. We multiply both sides by I. Then the left-hand side will be a perfect derivative of a product. So that means I can, if I integrate both sides, then the left-hand side is just going to be I times y. So I have I times y is equal to some integral, which hopefully I can integrate. But if I cannot, I can just leave it as an integral. Don't forget plus c. And then I solve for y by dividing both sides by I and I simplify algebraically. And that's it. That's the integrating factor method. Thanks for watching. Bye.